Let me give you a brief representational state transfer introduction, a brief rest. What are web services? This is a system designed to support interoperability among systems that are connected over the network. Web services is a service-oriented architecture. Somebody provides a service, somebody else consumes the service provided by the other person. So this is a standardized way of integrating web-based applications using open standards so that clients can communicate with servers. There is a standardized way of exchanging information between the two sites. There are two common approaches that people take for implementing web services. One approach, called as Simple Object Access Protocol, or SOAP, uses something called the Web Services Description Language. SOAP uses XML as the representational approach. The other approach that has been widely used is called REST, or Representational State Transfer. So this uses web standards. The data exchange can happen either using XML or JSON. Now, in terms of usage, REST is simpler compared to SOAP and WSDL, but gets the work done. Of course, SOAP and WSDL have a lot more features that are more suitable for distributed operation across the internet. But for typical web applications communicating with a server, REST seems to work just fine. So what is representational state transfer? It is a style of software architecture for distributed hypermedia systems like the World Wide Web. So REST is a more general concept than what we use in the World Wide Web. You have a hypermedia system, so you have hyperlinks to resources on the other side and so on, which you can refer to resources using hyperlinks. This concept was introduced by Roy Fielding. He is a doyen in the HTTP world, or the World Wide Web area. So you really should pay attention to what he is saying. Now, he published this as part of a PhD thesis. One of those PhD theses that was really useful. What exactly is REST? Again, it's a collection of what he called as network architecture principles, which specify how you can identify resources, how you can access them, how you can address resources, and how you can perform operations on those resources. Now, when REST was proposed, there were four basic design principles that underpinned the design of REST. One was that you should use HTTP methods explicitly. Second, it has to be stateless. Third, resources should be identified using URL-like structures, directory structures like URLs. And transfer of information should be in the form of either XML or JSON so that it's more easy for information to be communicated from one side to the other side. REST draws a lot of inspiration also from HTTP, the way the World Wide Web has been so successful. Now, the World Wide Web was successful because of the hyperlinks. Being able to refer to other resources on the internet using uniform resource locators. So that is what REST leverages in providing its functionality. So you have resources that are addressed by uniform resource identifiers, URIs, that look like URLs that we are familiar with from the World Wide Web world. Second, all these operate on top of HTTP protocol. Third, Whenever you need something, you make a request, you receive a response, and then you will deploy the response. So this cycle of operation is what underpins REST. Now, REST makes use of all the different methods that HTTP provides, not just post and get, but also put and delete. Also, it tries to preserve idempotence. Some operations, when they are performed even repeatedly, will not cause any change of state. Some other operations, if you do them successively, they may cause a change of state. So you need to be careful about which operations can be repeated without any damaging consequences, and which have to be very carefully done. In the REST world, you often hear people talking about nouns, verbs, and representations. This is the REST grammar. What are nouns? Nouns are the resources that you can access over the network. The resources are addressed using uniform resource indicators. They look like your HTTP addresses that you are familiar with. So you will have some host name followed by a slash, followed by some additional path-like structure. Then you have verbs. Verbs specify what should be done. And verbs are constrained. They have a reason, meaning, and a purpose for their existence. So you have verbs like put, post, get, delete, and so on. And each of them has a meaning when they are invoked. Third, you have representations. How do you represent the data when it is being transferred from one side to the other side? And this is where both XML and JSON have been leveraged to serve this purpose. REST is driven by resources. Resources are information that you can access over the network. So it's a conceptual mapping to a set of entities. Any information that is stored can be a resource, like a document, an image, a video, or any collection of data that is available in a server can be a resource. Now, every resource is addressed using a uniform resource indicator, or URI. An example is shown in the picture. So this case, you can easily read that and say, oh, probably you're referring to the dish number 123 in the collection of dishes. As we realized, REST uses URIs to identify resources. And the way the URIs are specified is that there is a path-like structure when you identify resources. When you specify something like some website /dishes/ without a number, then you are assuming that you are addressing a collection of dishes. And if that is followed by a number, you are sort of expecting that you are referring to a specific dish in that collection. Similarly, promotions, leadership, and so on. So here you have a way of specifying a generic set of resources and a specific resource from that set using this path-like representation. So that is what brings the advantage of using the REST approach for identifying resources. The second aspect that we talked about for REST was the verbs, trying to do actions on the resources. What kind of operations you want to be performed on the resources. And the 4 HTTP verbs have been mapped to CRUD operations, create, read, update, and delete operations that you can perform on the server side. The get verb has been mapped to the read operation. So when you do a get on any resource, you are getting a representation of the resource. It doesn't modify the resource in any way. A post operation creates a new resource. So when you do any post operation to a server, the expectation is that the server creates a new resource. That resource did not exist before you created it. This may be useful, for example, when you upload a new file to a server. A put operation updates an existing resource. So that's why you do put operations whenever you need to modify something on the server side. A delete operation deletes an existing resource, as you would expect. So the get is mapped to read, post is mapped to create, put is mapped to update, and the delete is mapped to, of course, delete. That's the reason when you perform any of these operations, you are expecting that kind of behavior to happen on the server side. And from the client, you are able to express to the server side what is it that you want the server to do. So this is the get operation, for example, is used for the clients to request information from the server. So you could request information for a collection of resources. So if you say get, for example, confusion food / dishes / you're expecting the information about all the dishes to be returned. If you identify a specific dish with a number, you are expecting information about that specific dish. So the get operation, depending on how you specify the URI, it is clear to the server side what kind of information it is supposed to send back to you. The post operation, as I said, creates a resource. So if you specify, for example, in the assignment, you're going to be doing a post operation on this URI called as confusion. You will in the assignment you will say localhost :3000 / feedback. Basically the same thing. What you are saying is you are creating a new resource. You are adding a new feedback form information to the collection of feedback information on the server side. So that's the post operation being done. A put operation is where you are modifying an existing resource. We're going to see the update being used to send comments that the user submits about a specific dish. The dish must already exist, otherwise the users cannot comment on the dish. So this would be an update operation to be done. So here you would use the put operation to carry out the update. A delete operation would be, say for example, you removed some item from your menu, you want to delete that item. So that would be a place where you would use a delete operation on a dish item. The third aspect, as I said, representations. How do you take this information on the server side and then transform it in a way that can be transported across to the client side, or vice versa, in a format that both sides understand? So this is where the representation takes on meaning. And the two formats for representing information that is transported across from one side to the other side is XML and JSON. So it's sometimes a server may be able to provide multiple representations of the same resource. So perhaps it could, if you access it requesting for an XML representation, it may be able to send you the information in the XML format. If you ask for the same resource information in JSON format, maybe it can send that in JSON format. Typically, JSON has become the de facto representational standard for information interchange. The server side in all this dance is going to be stateless. The server doesn't care what your client is or what the state of your client is. The whole burden of tracking state is transferred over to the client. This is for the sake of scalability. If the server needs to track state information about every client, then the server will pretty soon get overwhelmed. So for scalability, it is often a requirement that state information is tracked only on the client side. And when the client asks something from the server, then the client will send the full state representation information to the server to remind the server saying, this is where I am, and this is what I want you to do, and this is once you perform, inform me and I'll change myself to another state. And so I will remember everything. Your job is only to carry out the operation. So this is what a client is telling the server in this case. So the client has to track its own state on the client side. Server doesn't care about all these aspects. So this is where the MVC style of implementing comes to your aid in taking care of all these things. So that was a 10-minute quick introduction to REST. Now, the easier way to understand REST is to actually use it in practice. That is what we're going to do in the exercises that follow next.